Hey, now this lecture, continuing on, I just thought I'd make them shorter and smaller, and maybe that helps everybody out. This is section 5.8 in your notes, and it has everything to do with special right triangles. And the two special right triangles we're going to talk about are 45-45 90s and 30-60 90s. So take a look at this diagram. This is a theorem, and it states that in a 45-45 90 triangle, the hypotenuse is equal to the length of the short side times the square root of 2. Okay? And again, this has to be isosceles. The legs are the same. The hypotenuse is the leg times the square root of 2. The key here is to not overthink it. If you overthink it, you're going to suffer. All right, let's take a look. Hey, this side's 45, right? That means this side has to be 45. Therefore, I know that these two angles are congruent. By the converse of the isosceles triangle theorem, I know these sides have to be congruent as well. Well, therefore, the hypotenuse, x, right, the hypotenuse, x equals the leg, 8, times the square root of 2. That's it. The hypotenuse is 8 times the square root of 2, or 8 square roots of 2. Don't overthink it. And don't forget, the square root of 2 is a number. It's just irrational. It goes on forever. It's like 1.41, blah, 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 blah. It just keeps going. So at some point you have to round it, or if you don't want to round it, leave it as an exact answer, the square root of 2. Now on this side here, what's so interesting is 5 is the hypotenuse. So I know that this is an isosceles triangle, right? Therefore these have to be the same, right? And since this one's 90, the sum of these two have to be 90, and that means they both have to be 45s. So basically what I'm telling you is you need to recognize, step one is to recognize that that is a 45-45 90 triangle. Step number 2, once you recognize it, then apply that 45-45 90 rule. Now, you know the hypotenuse is 5. Well, you know that the short side, x times the square root of 2 equals 5. Well, that's fascinating. So what does x have to be such that I can multiply it by the square root of 2 and get 5? Well, hey, solve for x. So let's do it. Divide both sides by the square root of 2. All right. And again, I apologize for the slow clicky mouse, but I mean, it's the best I can do. So x equals 5 divided by the square root of 2. Now, if we lived in an imperfect world, we could leave our answer like that. But we live in a perfect mathematical world, which states that you may not leave your final answer with a radical in the denominator. What? No big deal. We just practiced this the other day. How do you get rid of a radical in the denominator? Multiply it by 1. And notice I'm doing this in red because the square root of 2 times the divided by the square root of 2 is 1. Math magic, right? Nope. Okay, so here we go. What do you end up with? The square root of 2 times the square root of 2 is just 2. And then 5 is a whole number. The square root of 2 is in simplest form. So I've got 5 square roots of 2 divided by 2. And that is in simplest form. So again, 5 square roots of 2 over 2 is this side right there. Very interesting. Yes. I think at this point, you should be able to complete the first few problems on your worksheet. I'm now going to show you the next set of problems, and it has to do with a 30-60-90 triangle. Okay, you're back, you've paused, you've done your problems. Now, what's interesting here, and let's just read it. In a 30-60-90, the length of the hypotenuse is twice the length of the short leg, and the length of the longer leg is the length of the short times the square root of 3. So S is the short leg. S square roots of 3 is the long leg, and 2s is the hypotenuse. So You might want to write that out. It would take me a long time to write this with my little mouse thing. But again, this is the short leg. Short. I see, I can't even write it. Long. O's with a mouse, I'm telling you, they're really hard. And of course, hypotenuse, or longest. HYP, okay? The way to remember the difference between, on a 45, 45, 90, it's really a 45 and a 90. It's S and S times the square root of 2. This 30, 60, 90, it's 1, 2, 3. And remember, 1, 2, and the square root of 3 is in between 1 and 2. If you do that on your calculator, you get like 1.7 something, right? And that's an important thing to remember, that it is 1, 2, square root of 3, but that square root of 3 is between 1 and 2. Let's try a couple of problems, and you'll see how this plays out. So on this one here, the hypotenuse is 22. Well, x, well, let me read it this way. 22 equals 2 times the short leg, or x. Well, and then that's pretty easy just to divide both sides by 2. And you got to know that 11 equals x. Again, once you have that short leg, then life should get a lot simpler. The question is, what do I have to do for y? Well, y equals 11 times the square root of 3. That's it. You're done. You've simplified it completely. I know x is 11 and y is 11 squared root of 3. Now on this one here, again, I know it's a 30, 60, 90. That's wonderful. Ooh, I know this is 15. They gave me the long leg. Oh, they're making me do the work. Hey, I can handle doing a little work because I know that 15 equals the short leg, x, times the square root of 3. Well, sweet. In order to solve for x, I'm going to start with the short leg, right? I just have to divide it by the square root of 3. What I do to one side, I got to do to the other side. And of course, once again, they leave you a little radical in the bottom. But you're not panicking. You're not freaking out, right? You're looking at that saying, hey, Mr. Rising, I can handle that. And you know what, Rihanna? You're right. You can handle that. And Kirsten, you can do it. So let's do it. Square root of 3 divided by the square root of 3. Again, square root of 3 divided by the square root of 3 is 1, so I'm not fundamentally changing the value of anything. What is going to happen here is really cool. When I simplify this out, I get x equals 15 square roots of 3. And again, what is the square root of 3 times the square root of 3? You named it, 3. But I can simplify 15 square roots of 3 divided by 3, and that is simply 5 times the square root of 3. So I know up here now that this is 5 square roots of 3. And I know that the hypotenuse is twice that. So this is equal to 5 square roots of 3, or 2 times 5 square roots of 3. Boy, this must be hard watching me try to write this out with a mouse. Yikes, I got to figure out a better way to do it. You know what? I can simplify that. What's 5 times 2? 10. So that means my hypotenuse is 10 times the square root of 3. All right, I might have another example here for you. Let's take a look. Oh, I do have one more example, and then a couple of other things. On this one, you see that I give you the hypotenuse. Okay, well then, if the hypotenuse is 18 square roots of 3, x is half of that. And you're looking at me like, Mr. Rising, how can you just look at that and say that's, well, all I'm doing to get x is equal to, I should maybe rephrase that. Hypotenuse is equal to x times 2. right? And the hypotenuse is 18 square roots of 3. So in order to solve for x, I divide both sides by 2. Hold on, Tyler, come on in. And then I can solve for x. The real question then is y. So y is equal to the short leg, 9 square roots of 3. Tyler just walked into the room, so he gets to watch this lecture. It's pretty cool. Times the square root of 3. Square root of 3 times the square root of 3 is? Right, very good, Tyler, 3. So now it's a simple matter of what's 9 times 3, and that's 27. Let me pause the video here. Oh, my mouse just goofed up. See that number? That's supposed to be a 27. Actually, give me one. Let me just pause. Hey, Tyler, thanks again for your help. That really, just everything was great there. I think you guys can do the next set of problems here, and I'm going to move on to the last example. So if you want to pause, do your problems, and come back. Okay, here we go. So the last problem, and I've got just a few minutes to wrap it up. It says an ornamental pin is in the shape. No! The bell, all the kids are going to come in. Is in the shape of an equilateral triangle. Okay, equilateral means all sides are the same. That's very important to note. The length of each side is 6. Okay? Josh will attach the fastener to the back along AB. Will the fastener fit if it's 4 centimeters long? So is AB greater than or equal to 4? And so that's the big question. Well, let's break this down. I know that if this is 6, half of it has got to be 3. So let me just put 2 little marks there. So I know the total thing is 6. Hi, Jack, come on in. But really, half of that is 3. And you might be saying, well, how do I know that this half is 3? Well, it bisects it perpendicularly. I mean, I know I'm cutting this in half, so this creates a 30, 60, 90 triangle. All right? So you don't have to take my word on that. So the real question is, again, I know that's 60, I know that's 90, that's got to be 30, so it's a 30, 60, 90. Therefore, I know AB is equal to 3, the short leg, times the square root of 3. Well, where's my handy trusty calculator? Right behind me. On my calculator, I do 3 square roots of 3. Let's see if you can see that. Look at that, 3 square roots of 3 equals 5.19. Is 5.19 greater than 4? Yes, it is. Therefore, it will fit. I think you have enough information now to finish the worksheet, so please do that. And let's get rolling here for next week. We've got to finish up the unit and get ready for finals.